Alright, so in this video we are going to be covering the different forms of quadratic equations. Of quadratic equations. And what I mean by that is that quadratic equations can come in several different ways. We can see them in many different ways. One of them being the standard form, another being the factored form, and the final being the vertex form. So what we're going to ask ourselves is, why are there three different forms? And why would we need three different forms? And what are the advantages of each of these forms? And also, why do you need to know them? Why can't we just do one form of a quadratic equation and be happy with it? Okay, so as I mentioned, there's three different forms. The first one we'll cover is the standard form. Okay, so standard form. So the standard form of a quadratic equation is going to look like y equals ax squared plus bx plus c. Okay, where a, b, and c are just some numbers. Okay, they can be fractions, they can be decimals, they can be whole numbers, they can be positive, they can be negative. They're just numbers. A, b, and c are just numbers, and of course x and y are our variables. And the only other extra thing that I'll say is that a can't be 0. Because if a was 0, then really what would happen is this first term would be missing, right? 0 times anything is 0. And we would just have bx plus c, which if you remember back to linear equations, looks very similar to mx plus b. In fact, it's the exact same thing. Mx plus b, m and b were just numbers, and in this case b and c are just numbers. So we need to have a be any number other than 0 here, because 0 would mean we get rid of the x squared term, and if we get rid of the x squared term, well, we don't have a quadratic equation anymore. We have a linear equation, and that's not what we're studying. Okay, so this is the standard form of a quadratic equation, and we can ask ourselves, okay, what is this? What does this tell us? Okay, this tells us the end behavior. Okay, end behavior. This may be a new word, but really all this means is it opening up or down? Okay, so open up. That means a is positive, or it's gonna open down, in which case a is negative. Okay, so that's all that end behavior means. It just means, is our graph opening upwards or downwards? And if a is positive, it's opening upwards. If a is negative, it's opening downwards. Okay, and the other thing that this is going to tell us is it's going to make it really easy to use. Okay, so easy to use in our quadratic, not equation, but formula. Okay, so the quadratic formula is going to be something that we're going to learn about a little bit later, and it's going to help us find certain properties of a quadratic equation mathematically. And it's really useful. It's kind of used as a last resort, but it's really useful if we need to use the quadratic formula, because in the quadratic formula, you need to know what a, b, and c actually are. You need to know the values of those numbers to put it in your quadratic formula. And so it'll make it really easy to use in there. So that's kind of the advantages of the standard form. Okay, what about factored form? Okay, so let's move on. Factored form. So the way that the factored form of a quadratic equation is going to look like, it's going to be y equals a multiplied by x minus s1 times x minus s2. Now this might look confusing because there's an s1 and an s2 here, but just stick with me here. Again, a is the same a that is over here. Okay, a is just a number. S1 and S2 are also just numbers. And the reason that I labeled them S1 and S2 is because they are solutions uh, to our quadratic equation, and I'll let you know what I mean by that. But first, let's go over some of the things that it gets us. So the first thing, again, we have an A here, so it's gonna tell us the end behavior, right? It's gonna tell us if this is if it opens up, if A is positive, and opens down if A is negative. So that's good. Tells us the end behavior. And the second things, it gives us the solutions. Okay, and what does that mean? The solution is the x-intercept. Okay, and it's also sometimes known as the zeros or the solution to the quadratic equation. The reason it's called the zeros or the solution is simply because the zeros is because it happens at, well, where your graph meets the x-axis, and the x-axis is located at y equals 0. So it's at the zeros. If we set y equal to 0, that's what we get. We get the zeros. And the solution is just, it's the solution, it's a number specifically that fits into S1 and or S2 that will make this y equals a times x minus S1 times x minus S2. It'll give us the proper solution. I can't just put any number into S1 and S2. I need to find the specific number, and that will give me the correct solution. So that's why it's called the zeros or the solution. So basically all I'm saying is this helps us get the x-intercept really easily. And the way that we get the x-intercept, again, we'll go over this in a bit more detail once we cover methods of discovering properties of quadratic equations, is basically you're going to take x minus s1 and set it equal to 0, and then you're going to solve for x, because remember s1 is just a number. You're going to have a number here. You're going to solve for x, and you're going to take x minus s2 and set it equal to 0, and you're going to solve for x again. Okay, and sometimes you will get no answer, sometimes you'll get one answer, and sometimes you'll get two different answers from the s1 and the s2. And again, that kind of makes sense because remember, in terms of graphs, you can either have it cross the x-axis 0 times, you can have it cross the x-axis 1 time, okay, or you can have it cross the x-axis 2 times. And so you can either get 0 solutions, 1 solution, or 2 solutions, depending on what happens here. Okay, so that's our factored form. And the last one that we have is the vertex form. Okay, the vertex form. And you might be able to guess what this is going to give us, but we're still going to go over it. So the vertex form is going to look like y equals a times x minus h squared, okay, plus k. Okay, this is our vertex form. Okay, and again, what does this give us? Well, it's going to give us the end behavior. Oops, the end behavior, okay, because we have an a here, we have the a that's stuck with us through all three of these forms. So it tells us the end behavior. And the other thing that it tells us, as you might guess, is the vertex, okay? Hence why it's called the vertex form. And the way that we're going to figure out the vertex is just h, k. That's where the vertex is, okay? So the vertex is located at this number h, comma this number k. Okay, so the h is going to be your x variable, and the k is going to be your y variable. Again, no math needs to be done. We don't actually even need to draw this quadratic equation. We can figure out right away where the vertex is, and also, since we know where the vertex is, we know where the axis of symmetry is. So that's what this vertex form is useful for. Okay. And the last thing that I just wanted to mention here is I wanted to write out a quadratic equation in all three of these forms, okay? And you'll see how much it differs, okay? So in standard form, we have a quadratic equation, and it's going to look like y equals 2x squared minus 3x minus 2. Okay, that's our quadratic equation. If I want to write it into factored form, and again, in the next video, we'll go over how to switch between these forms. But if I want to write it in factored form, it's going to look like y equals x minus 2 times 2x plus 1. Okay, and if I want to see it in vertex form, it's going to look like y equals 2 times x minus 3 over 4 squared minus 25 over 8. Okay? And so we see three different equations here, but they're actually all the same equation. They all mean the same thing. They all show the same thing. If you were to take these three equations and graph them, they would be the exact same thing. You would see the exact same thing for all three of your graphs, okay? But they all give us different information. This one gives us the end behavior and is easy to use in the quadratic formula. The one in the middle here, the red one, gives us a really easy way to find the x-intercepts. Again, we just take x minus 2 and set it equal to 0, and we take 2x plus 1 and we set it equal to 0, and we solve for x. And the one in the vertex form gives us a very easy way to see the vertex. It's 3 over 4, comma, negative 25 over 8. Okay? So three different forms for quadratic equations, and they give us three very different pieces of information that are all equally as useful. Okay, so in the next video, we're going to discuss how to go over or how to go between standard form to factored form. Okay, so this way, and then we're going to go over how to go from factored form to vertex form. And of course, we're going to go backwards as well. We're going to go from vertex form to factored form, and we're going to go from factored to standard, and we're going to go from standard all the way to vertex, and vertex all the way to standard. Okay, so that's coming up in the next video.